Hi all, welcome to Anil Nair classes. Today in this session, we are going to discuss one of the most important sub-concept in number system, that is divisibility rules. Extremely important concept and very important concept from an examination point of view. What is the divisibility rule of different composite numbers? How to derive the divisibility rule of a prime number? All the variety of questions starting from the basic question to the advanced level, we will discuss through this YouTube live classes. Totally 4 sessions I am going to take only on divisibility rules. Ensure that each and every student who is watching the video kindly watch session 1 first, then session 2, then session 3 and then session 4. Kindly do not watch session 4 before watching session 1, 2 and 3. There will be few links that will be missing, thereby your understanding of the concept will be little ineffective. Let us straight away get into the class. Divisibility rules. I request each and every student to sit in the class with a notebook and a pen or a pencil. Everything whatever I am explaining, in addition to the solution, please make a note of it. Generally, most of the classes there is a question and there is an answer. But in my classes, beyond answer, I will be explaining you the W and H related questions. That is why, what, when and how. What if this value is changed, when this concept is applied, why this concept is applied, how this concept is applied. That is very important for a student to know, so that you can only start creating your own questions. At the end of the session, you will be able to solve most of the questions without the usage of pen and pencils. I will ensure that you use your fullest power of the brain. I will make you think logically, right? Less formulae based content, more conceptual content. Watch the entire lecture. Kindly do not leave the class in between. I will be starting from basics so that you will not miss out any of the important concept. Watch the entire lecture, and to get the best output from the lecture, kindly make a note of the important key points. Mathematical learning can never happen with the screenshots. The best way to learn mathematics is to take a pen and do some pen pushing in your notebook. Even though you are good, right? At the end of the class, I will make you better. At the end of all the sessions, I will make you best. Trust the 15 years of experience. Those of you who are new to me, who are watching my classes for the first time, kindly subscribe to the YouTube channel so that you will not miss any of the class notification. I will be coming regularly on the YouTube channel and I will be taking a lot of YouTube live classes. The sad part about my classes is, right after my class is over, the class will be available only to the enrolled students. Non-enrolled students can watch it only once when the live class is going on. I might have taken more than 500 times, more than 1000 students in a class. Generally, my class will have a huge gatherings of 2000, 3000 students sitting in the class. In case you got any doubt at the end of the class, feel free to mail us at support@anilnairclasses.com. Divisibility rules, 4 sessions. Straight away, let us get into it. Now, those of you who are new to me, right, we are ranked number 1 by Google reviews all over India. 3,643 students has rated us at 4.8 out of 5. Why this many people gave such a high rating? You will understand as the class proceeds. Now, divisibility rules. Divisibility rules. Now, suppose there is a number 12 divided by 3. How to check whether 12 is divisible by 3? Suppose there is another number 6 ones divided by 7. General division, there is one method. General division is very complicated. You have to take the number and you have to do the generic division. This division is a very complicated process. That's the reason, right? We have developed some divisibility rules for composite numbers. Composite numbers is quite easy, right? But I will also be discussing the divisibility rule of a prime number. divisibility rule of a composite number and divisibility rule of a prime number, right? By knowing these divisibility rules, you can check whether the number is perfectly divided by this number, what is the remainder of this number. Your life becomes very easy, unlike going through a generic division, which is a very painful process. By knowing these divisibility rules, you can use the concepts and solve most of the questions just through a sheer observation or sometimes with a little bit of pen pushing. Divisibility rules. How the questions will be asked? Now see this question. There is a number that is given 1, 2, 3, 4, 5, 6, 7, 8, 9. He is asking what is the number remainder when a number is divided by 2, when a number is divided by 5, when a number is divided by 10. Generic division I am not interested. So there is a question and he is asking what is the remainder when the number is divided by 2, 5 and 10. So what I will be doing is I will be discussing the concept 1, divisibility rules for 2, 5, 10. Divisibility rule for 2, 5, 10. We'll start from basics, then we'll go to the advanced level. 2, 5, 10. If you know the divisibility rule of 2 and 5, automatically 10 will come, because any divisibility rule of a composite number can also be found out from the product of co-prime numbers which results in the other number. 10 is nothing but 2 and 5. So the combination of 2 and 5 will result in 10. Divisibility rule for 2, 5 and 10. Now first we will discuss take a 2-digit number. Let there be a 2-digit number AB. B is there in units place. A is there in tens place. So the value of A will become 10 into A, because A is there in tens place, the value of A will become 10A. This can be written as 10A plus B. Am I right? For example, 2, 3. 2 is there in tens place, so the value will become 2 into 10 plus 3. Am I right? 10A plus B. Now 10A plus B. Suppose if 10A plus B, if AB is divisible by 2. I said that this 2-digit number is divisible by 2. That means AB is divisible by 2. 10A. 10 is nothing but it is divisible by 2. This number is divisible by 2. This number is divisible by 2. Obviously, B should also be divisible by 2. Why? Because, for example, 20 is nothing but 12 plus 8. 20 is divisible by 2. 12 is divisible by 2. 8 should also be divisible by 2. Again I am repeating, if AB is divisible by 2, any number divisible by 2 is called as an even number. That means if AB is an even number, 10 into A, any number multiplied by 10, 10 is nothing but 2 into 5, that is also divisible by 2. AB is divisible by 2, 10A is divisible by 2, B should also be divisible by 2. B should also be divisible by 2 means B should also be an even digit, or B should take a digit which is nothing but an even number. That means B can take either 0, B can take either 2, B can take either 4, 6 or 8, because these are nothing but the even digits 0, 2, 4, 6, 8. So what is the conclusion that we have drawn from these AB? If AB is an even number, that means B should also be an even number or even digit, because B is a digit, it will obviously take a digit value. That means for a 2-digit number to be an even number, unit digit has to be an even number. Unit digit has to be an even number. Why only unit digit has to be an even number? Because other part is already divisible by 2. Now you might ask me, Anil sir, is this valid for 3-digit numbers, 4-digit number, 5-digit number? Yes beta, it is valid for every n-digit number. Let me take a 3-digit number. Suppose if I take a 3-digit number. Suppose if I take a 3-digit number, A, B, C. A, B, C. C is there in units place. B is there in tens place. So the value will become 10B. A is there in hundreds place. So the value will become 100A. B is present in tens place, so the value of B became 10 into B. A is there in hundreds place, so the value of A became 100 into A. If ABC is an even number, if ABC is an even number means it is divisible by 2. Any number divisible by 2 is also an even number. 100A is divisible by 2. 10B, it is divisible by 2. C should also be divisible by 2. That means C can take 0, 2, 4, 6 or 8. C can take 0, 2, 4, 6 or 8. That means even for a 3-digit number to be an even number, unit digit has to be an even digit. Unit digit has to take an even value. That means for a 2-digit we did it, for a 3-digit. You don't need to do 4 digits. 4 digits means it will become C. B is there in tens place, 10B divisible by T. A is there in hundreds place, divisible by T. E is there in thousands place, 1000 is divisible by T. Any power of 10 from 10 power 1 onwards, 10 power 1, 10 power 2, 10 power 3 and so on, it is divisible by 2. So the only thing that you have to consider is unit digit should be an even number. Unit digit should be an even number. So the first important concept for divisibility rule for 2 is divisibility rule for 2. Divisibility rule for 2 is unit digit should take an even value. 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 What do you mean by an even value? It can be either 0 or 2 or 4 or 6 or 8. You don't need to divide the entire number. Just take the unit digit of that number and divide it by 2. You will get the remainder when it is the divisibility rule for 2. I hope it is clear. Similarly, what is the divisibility rule for 5? Divisibility rule for 5. What is the divisibility rule for 5? Because I explained it 2, right, with multiple examples, 5 I will restrict it. If I take a 2-digit number AB, A is there in tens place, so it is nothing but 10A plus B. 10A is divisible by 5. That means B should be divisible by 5. Example, 25 equivalent to 15 plus 10. 25 is divisible by 5, 15 is divisible by 5, 10 should be divisible by 5. Even if I take a 3-digit number, A is there in hundreds place, 100A plus 10B plus C, 100 is divisible by 5, 10 is divisible by 5, C should be divisible by 5. That means divisibility rule for 5 is unit digit should be 0 or 5. Any number multiplied by 5, it will give you unit digit 0 or 5. 5 2s are 10, 5 3s are 15, 5 4s are 20, 5 5s are 25. Divisibility rule for 5 says that unit digit of that number should be 0 or 5. Divisibility rule for 2 says that unit digit should take an even value. Even value is nothing but a value which is divisible by 2 including 0. Divisibility rule for 2, I hope it is clear. Divisibility rule for 5. The last one to solve our first question is divisibility rule for 10. Divisibility rule for 10. Divisibility rule for 10. Divisibility rule for 10. Any number you multiply by 10, unit digit will be 0. 10 2s are 20, 10 3s are 30, 10 4s are 40, 10 5s are 50, 10 6s are 60. Let me take an example. AB. A is there in tens place, so 10A plus B. If I take a 3-digit number, A is there in hundreds place, 100A plus 10B plus C. If AB is divisible by 10, 10 into any number divisible by 10, B should be divisible by 10. That means B can take only unit digit value 0, because any number multiplied by 10, unit digit will be 0. If this is divisible by 10, this is divisible by 10, this is divisible by 10, unit digit value should always be 10. Divisibility rule of 10 is nothing but the divisibility rule for both 2 and 5. Divisibility rule for 10 is nothing but divisibility rule for 2 and 5. What is the concept for 2 and for 2? Unit digit should be 0, 2, 4, 6, 8. Intersection. What is the divisibility rule for 5? Unit digit should be 0 or 5. What is common in both? Common in both is 0. That means divisibility rule for 10 is unit digit should be 0. Unit digit should be 0. I hope it is clear. Everything we will do by using proofs. Unit digit should be 0. Divisibility rule for 2 is unit digit should take an even value. Even value are nothing but because it's a digit, it will be 0, 2, 4, 6 or 8. Divisibility rule for 5 is unit digit should be either 0 or 5. Divisibility rule for 10 is any composite number, if it can be written as a product of two coprimes. Coprimes means their HCF is 1. HCF of 2 and 5 is 1. Take the divisibility rule for 2. Take the divisibility rule for 5. Do the intersection of these two. Intersection of these two is only one value, that is 0. So divisibility rule for 10 is unit digit should be 0. I hope the concept is clear. Now the questions can be solved very, very easily. Find the remainder when the number is divided by 2. When you are dividing a number by 2, the focus will be only there on the unit digit. Unit digit is 9. 9 when divided by 2. 2 4s are 8. Remainder is nothing but 1. I hope the concept is clear why we are dividing only by the unit digit. When a number is divided by 2, unit digit should take an even value. Question 2. Find the remainder when a number is divided by 5. When a number is divided by 5, unit digit should be either 0 or 5. Only focus is on unit digit. 9 when divided by 5. 5 ones are 5, unit remainder is nothing but 4. I hope it is clear. Question 3. Find the remainder when a number is divided by 10. 10 means unit digit has to be 0, but it is 9. Right? So answer is 9. Right? So if it is 0, answer will be 0. If it is anything other than 0, that will be the unit digit. In this first question, we discussed two important concepts. How to find the divisibility rule for 2, how to find the divisibility rule for 5, how to combine the divisibility rule for both 2 and 5 and do it for 10. Next one, next question, see here. Now we did only the preliminary concepts, that is 2, 5 and 10. What happens if it is beyond 2? In this slide, I will be discussing the divisibility rule for 4, 8, 25, 125, 100 and 1000. 4, 8, 25, 125, 100 and 1000. The first two are for the powers of 2. Next two are for the powers of 5. Next two are for the powers of 10. I hope it is clear. That's exactly the reason why I discussed the divisibility rule for 2, 5 and 10. Second question, I will do the divisibility rule for the powers of 2, powers of 5 and the powers of 10. If I start solving the second problem, first problem, if you know the first problem, understanding the second one is very easy. Vice versa may or may not be true. Find the remainder when it is divided by 4 and 8. Now, next, everything we will discuss the concept first. Divisibility rule for 4, 8. 4, 8. Then we will generalize it. Generalize for 2 power n. Then we will generalize for 2 power 1. Divisibility rule for 4, 8. Now, I will take a 3-digit number. For example, if I take a 3-digit number, if it is ABC, A is there in hundreds place, 100A. B is there in tens place, 10b plus c. 100a plus 10b plus c. Now if you see, if ABC is divisible by 4, if ABC is divisible by 4, 100 is nothing but 4 into 25. This is divisible by 4. 10b plus c should be divisible by 4. 10b plus c is nothing but the last two digits. Yes or no? BC can be written as 10b plus c. That means for a 3-digit number to be divisible by 4, last two digits should be divisible by 4. Last two digits should be divisible by 4. Last two digits should be divisible by 4. I hope the concept is clear. Is it valid for a 4-digit number? A, B, C, D. D is in units place. C is in tens place. B is in hundreds place. A is in thousands place. So 1000A plus 100B plus 10C plus D. 1000 is 4 into 250. 100A is 4 into 25. 10C plus D. Again it is nothing but the last two digits. That means for any n-digit number n greater than or equivalent to 3, it could be a 3-digit number, it could be a 4-digit number, it could be a 5-digit number. The divisibility rule of 4 is last two digits should be divisible by 4. Last two digits should be divisible by 4. Last two digits should be divisible by 4. Now, a very, very important conclusion. I will do it after I discuss the divisibility rule for 8. If I take the divisibility rule for 8, suppose if I take A, B, C, D, 1000 is 8 into 125. That means this entire number should be divisible by 8. Now, I want to optimize a few things. Now, if you see here, divisibility rule for 4. Divisibility rule for 4. What is the answer we got? Last two digits should be divisible by 4. Last two digits should be divisible by 4. Divisibility rule for 8. Divisibility rule for 8. What did we get? Last 3 digits should be divisible by 8. Last 3 digits should be divisible by 8. Can I also write it like this? 4 is 2 square. That is the reason I got last 2 digits. 8 is 2 cube. Last 3 digits should be divisible by 8. 2 power n divisibility rule is 2 power n divisibility rule is last n digits should be divisible by last n digits should be divisible by last n digits should be divisible by 2 power n. I hope it is clear. 2 is nothing but 2 power 1. That is the reason unit digit should be divisible by 2. If it is 4, 4 is 2 square. Last 2 digits should be divisible by 2 power n. If it is 8, 8 is 2 power 3. Last 3 digits should be divisible by 2 power 3. I hope the concept is very clear. 2 power 1 means 1 is unit digit. 4 is 2 square. Square means last 2 digits. If it is 8, 2 power 3. 3 means last 3 digits. 2 power 4, it is last 4 digits. That is how you can deduce the divisibility rule for 2 power n. I hope the concept is clear. 2 power n. Now, let me discuss the divisibility rule for 5 power n. Divisibility rule for 2 we discussed, then 2 power n. Then divisibility rule for 5 power n. 5 power 1. Suppose if I take a 3-digit number A, B, C. A is there in hundreds place. So 100A plus 10B plus C. 100A is divisible by 25 because 100 is nothing but 4 into 25. 100 is 4 into 25. That means 10b plus c. Again it is a 2-digit number. 2-digit number, last 2 digits should be divisible by 25. Last 2 digits should be divisible by 25. Now if you look at the divisibility rule for 5 power n, so we already discussed the divisibility rule for 5, where the unit digit has to be either 0 or 5. If I take a 3-digit number ABC, if ABC is divisible by 25, ABC is a 3-digit number, C is unit digit, B is a tens digit, A is hundreds place. 100A plus 10B plus C. 100A is divisible by 25. If ABC is divisible by 25, 100A is divisible by 25. 10B plus C should be divisible by 25. 10B plus C is nothing but the last 2 digits. Last 2 digits should be divisible by 25. Same concept for 2 power n. Last 2 digits should be divisible by. Last 2 digits should be divisible by 2 power n. Last 2 digits should be divisible by 2 power n. Same concept holds good for 5 power n. 5 power n means last n digits here. Last n digits should be divisible by. Last n digits should be divisible by 5 power n. There is no difference between the divisibility rule for 2 power n and 5 power n in terms of the face value. 5 power n means last 2 digits should be divisible by 25 if it is 5 square. Last 3 digits should be divisible by 125, it is 5 power 3. Last 2 digits should be divisible by 4 if it is 2 square. Last 3 digits should be divisible by 8 if it is 2 power 3. I hope the concept is clear, right? Idea remains the same because 100 is nothing but 4 into 25. 1000 is nothing but 8 into 125. If there is 2 power 3, there has to be 5 power 3 combination. Then only you will get the value of the digit at the thousands place. They both complement each other. Divisibility rule for 2 power n and 5 power n. You don't need to do 10 power n, right? So 10 power n is very simple. 100 into 1 is 100. 1000 into 4 is 1000. That means if I am multiplying by 10 power 3, last 3 digits will have 3 zeros. Last 3 digits will have 3 zeros if it is 10 power 3. If it is 10 square, last 2 digits will have 2 zeros. Last 2 digits will have 2 zeros. I hope it is clear, right? That means the divisibility rule for 10 power n is last n digits should be divisible by 10 power n. I hope it is clear. If you can get 2 power n and 5 power n, 10 power n is nothing but the product of 2 power n and 5 power n. What we discussed is just finding the concept behind the divisibility rule for 4, 8, 16, 25, 125. When we do problems, it will be much more clear with an numerical value example. Now see here. Question. Find the remainder when number is divided by 4. What is the divisibility rule for 4? Last 2 digits should be divisible by 4. Last 2 digits is 189. 189 when divided by 4. 4 22s are 88. What is the remainder? 1. Question 1 answer is 1. Question 1 answer is 1. Now question 2. What is the remainder when a number is divided by 8? 8 is 2 power 3. Last 3 digits should be divisible by 8. Last 3 digits is 789 when divided by 8. 8 9s are 72. 72 69. 8 8s are 64. What is the remainder? 5. Question 1 is divide only the last 2 digits by 4. Question 2 is divide the last 3 digits by 8. Otherwise, you will end up dividing the entire number by 8. You don't need to do it. Find the number when it is divided by 25. 25 means last two digits should be divisible by 25. 89 divided by 25. 25 threes are 75. Remainder is nothing but 14. Question 1 is clear, question 2 is clear, question 3 is clear. Question 4. Question 4. Find the remainder when a number is divided by 125. 125 is 5 power 3. That means last 3 digits should be divisible by 125. Last 3 digits is 789. 789 divided by 125. 125 5s are 625. From 789 625. If I subtract, which is nothing but 164, right? 625 plus 164 is 789. Only the last 3 digits we did it. 1, 2, 3, 4, it is clear. Find the remainder when n is divided by 100. 100 means last 2 digits. When you divide a number by 100, what you have to do is just take the last 2 digits of the given number. When you divide a number by 100, take the last 2 digits from the given, from n. Last 2 digits from n is nothing but the remainder. When you divide a number by 100, last 2 digits is nothing but 89. Answer for this question is 89. Question number 6. When you divide a number by 1000, it is nothing but the last 3 digits from n. Only take the last 3 digits from n. Only take the last 3 digits from n. Last 3 digits from n is nothing but 789. 789. Extremely important set of questions. The divisibility rule for 2, 5 and 10 is question number 1. Divisibility rule for 2 power n, 5 power n and 10 power n is question number 2. These especially 5 and 6 are extremely important when you are doing the remainder, when you divide a number by 100 and 1000. When you divide a number by 100, you will get the last 2 digits of a number. When you divide a number by 1000, you will get the last 3 digits of a number. When you know the divisibility rule for 2 power n and 5 power n, 10 power n is nothing but the combination of 2 power n and 5 power n. I hope set of these 6 examples are very, very clear. Now, next one, we did 2, we did the power of 2. We did 5, we did the power of 5. We did for 10, we did the power of 10. There are certain more composite numbers that are there. That is the divisibility rule for 3, divisibility rule for 9. Now we will do first of all divisibility rule for 3. What is the divisibility rule for 3? Divisibility rule for 3, 9, 27, in general 3 power k. Divisibility rule for 3, 9, 27 and so on. Example, if I take a 3-digit number A, B, C. A is there in hundreds place, 100A. B is there in tens place, 10B plus C. This can be written as 99A plus 9B plus A plus B plus C. If ABC is divisible by 3, assume that the left hand side is divisible by 3. 99A is divisible by 3. 9B is divisible by 3. A plus B plus C should be divisible by 3. What is A plus B plus C? A, B and C are the digits for the number ABC. What do you mean by A plus B plus C? Sum of the digits should be divisible by 3. A plus B plus C is nothing but the sum of the digits. A plus B plus C is nothing but the sum of the digits. That means for 3 I got it. Assume if ABC is divisible by 9, Left hand side, if it is divisible by 9, 99, it is divisible by 9. These also divisible by 9. A plus B plus C should be divisible by 9. That means not only for the divisibility rule for 3, but also for the divisibility rule of 9. What is the concept I am getting? Sum of the digits should be divisible by. Sum of the digits should be divisible by 3 or 9 or 27 or whatever it is. Or we will do first for 3 and 9. I hope the idea is clear. 3 and 9 first we will do it, because first the questions are based on 3 and 9. Then obviously we can elaborate it for 27 also. Divisibility rule for 3 and 9 is nothing but sum of the digits should be divisible by 3 and 9. Right? For 3, sum of the digits should be divisible by 3. For 9, sum of the digits should be divisible by 9. I hope the idea is clear. If I am doing it for a 3-digit number, the same proof also holds good for a 2-digit number or a 4-digit number or a 5-digit number, so on and so forth. Idea clear? Now we will solve the problems. Question 1. Find the remainder when a number is divided by 3. When a number is divided by 3. 1, 2, 3, 4, 5, 6, 7 when divided by 3. Sum of the digits should be divisible by 3. So take the sum of the digits wherever it is 3, scratch it off. 1 plus 2, 3, cancel. 4 plus 5, 9, divisible by 3. 6 is divisible by 3. 7 divided by 3. 3 2s are 6, remainder 1. I hope the idea is clear. Delete the digits whose sum is 3. Sum of the digits should be divisible by 9. The same thing for also for the number when it is divided by 9. 1, 2, 3, 4, 5, 6, 7 divided by 9. 6 plus 3, 9. 5 plus 4, 9. 7 plus 2, 9. 1 divided by 9, 1. I hope the idea is clear. Question 1, I hope it is clear. Question 2, I hope it is clear. Now see, question 3. Question 3. Find the remainder when a number is divided by 18. 18 can be written as a product of two coprimes, 2 and 9. I hope it is clear. Always whenever a composite number is there, write it down as a product of coprimes. Write it down as a product of two coprimes. Write it down as a product of two coprimes. 15 is 3 into 5. 24 is 3 into 8. 40 is 8 into 5. So 18 is 2 and into 9. Now 2, what is the remainder when this number is divided by 2? Unit digit should be divisible by 2. 7 divided by 2. 2 3s are 6. Remainder is 1. Similarly for 9. 9, what is the remainder? We got 1. That means a number when divided by 2, it gives a remainder 1. A number when divided by 9, it gives a remainder 1. Both are for the same number, right? So equate it. Both are equated with A0 or B0. Am I right? 2A equivalent to 9B. That is only possible when A is 0 and B is 0. A0. 2 into 0 plus 1. 1. So answer is, the form of the number is, the lowest remainder is 1. Every time it is divisible by 18k. 1 plus 18k divisible by 18. Answer for this when the number is divided by 18 is 1. Again I am explaining you the third question. Third question, find the remainder when a number is divided by 18. First of all, 18 is a composite number. Second step, I wrote 18 as a product of two coprimes, which is 2 and 9. Step number 3. I know the divisibility rule for 2. Unit digit should be divisible by 2. 7 when divided by 2, it gives a remainder 1. I know the divisibility rule for 9. Sum of the digits should be divisible by 9. I did the sum of the digits, I got a remainder 1. Answer when divided by 2, it gives a remainder 1. Answer when divided by 9, it gives a remainder 1. Both are for the same number. So 2a plus 1 equivalent to 9b plus 1. 1 1 cancel. 2a equivalent to 9b. Both are same at a0 or b0. a0, if I did it 2 into 0 plus 1, 1. Answer for this question is 1. What is this 1 plus 18k? 1 plus 18k is the form of this number. 1 plus 18k when divided by 18, remainder is 1. I hope it is clear. Slowly, steadily, we will increase the level of difficulty. We will increase the level of difficulty.